Okay, let's begin then. So that was quiz number 1. Thank you. And I'll have them graded and returned to you by next week, okay? Please don't email me asking what you got on the quiz. I'm just going to ignore and delete those emails. So you will get the quizzes will be returned next week. They will be graded, and you can find out what you get. There are 30 points possible. Okay. I grade them out of 25, and that is just a way for me to kind of boost everyone's grade that way. So if you score 25 points out of 30, so that would normally be minus 5 points, which would be like an 83%, you would get 100% on the quiz, okay? And if you get 20 points on the quiz, which is you're missing 10 out of 30, so that's really like a 67% or a D, you would actually get 80% in the grade book, okay? That said, don't let that deceive you, okay? It's just a way for me to help everyone's grade out. And so if you get 20 points on the quiz, that's a lot closer to a D than it is a B, even though in the grade book it goes down as an 80%. Okay, so sometimes students will email me at the end of the quarter or after the midterm, and they say, "Well, I did so well on the quizzes, and I did poorly on the exam. What's going on?" Well, the truth is you probably didn't do that great on the quizzes, okay? It's just because I'm giving pretty much a 20% boost to your quiz grade, which in my opinion is very generous, okay? And so, because if you get all of the questions right, it will go down in the grade book as a 120%. So anyway, I'll have those graded and returned to you next week. Okay. If you don't come next week, I won't always bring the quizzes to class, so it might be a while before you get your quizzes back. Okay. So come next week if you want to get your quizzes back. All right. Sorry, I have to tuck my shirt in because I think if it touches the mic, it creates these static pops. Okay, so just I want to emphasize the importance of your prerequisite math. It's already the 3rd week, so if you're still here, that means you are committing to staying in the class, or at least you have passed the refund deadline. So you could choose to withdraw, but it will be at a loss. I think some students struggle with arithmetic and mental math, and that's an important skill. Okay, it's an important skill for life, but it's very important for this class as well. Okay, you should be able to subtract numbers from 100 quickly, per se. Okay, so if I say, what's 100 minus 82, you should be able to say that's 18, okay? These types of computations are important, and I would, if you were not able to say 18 before I did, then I would emphasize working on just some mental math drills. Just because as we're going through class, I'm going to do some computations fairly quickly, and at least you'll understand where these numbers are coming from. Whereas if you didn't, if some of these skills were not present, maybe these numbers would appear like they're just you have no idea where these numbers are coming from. Okay, and so it's important to your understanding. of the material in this class. Okay. One more thing. After this quiz, if you feel like you didn't do that great, I encourage you to review the materials from chapters 1, 2, and 3, okay? Especially chapter 3. And know the concepts of middle. So you understand the mean and the median. Not just how to calculate them, but what they are saying about the data. Also understand concepts of spread. So the standard deviation, the range, and the IQR. Not just how to calculate them, but also what they mean. Okay, so I think you'll have a sense, I think most of you have a sense of how you did on the quiz. If not next week, you'll definitely find out how you did. But make sure you understand those things well. Okay, we're going to move on to chapter 4. And I apologize, I'm going to have to use colored chalk today. The normal chalk that I use, it seems that it has emptied out. So I've got some orange colored chalk. I hope that's fine. Okay. So chapter 4 is all about relationships between numeric variables. And so, when we're talking about a numeric variable, we're talking about things like age, height, weight, how many siblings someone has. Things that tell us how much or how many. In chapter 4, we are dealing with numeric variables again. And this time, we are gathering at least 2 numeric variables for each subject. So each subject will have 2 numeric variables. So for example, we could go around the classroom and I could ask, what is your age and how tall are you? Okay. Everybody here would provide 2 numeric variables. You would tell me your age, that's your first numeric variable, and you would tell me your height, that would be your second numeric variable. So every person would have at least 2 numeric variables. So, or at least in this data set, would have exactly 2 numeric variables. So in our data set, each person or each subject has 2 numeric variables. Student for age, and height. Okay, so each student has 2 values associated with them. Okay. So, for example, in our classroom, so that's XL10, the data that we collect might look like this. So we would have the student, the age, and the height. I don't know if anyone is willing to volunteer their age and height, but you can just shout it out, but I could also just make up some numbers. So maybe there is a 24-year-old who is how tall?
4 feet.
What?
6'4".
6'4", okay. 76 inches, okay. Maybe there's a 22-year-old who is 5'10", 70 inches, okay. And maybe a 28-year-old who is 5'4", and maybe someone who is 21 who is 5'8", and so on and so forth, okay? So you can imagine each student, we would have names for each of these, but more data, okay? Et cetera, et cetera, et cetera, okay? So you can imagine gathering age and height data for all the students in our class. Okay? If we were to look at this data, do you think we would see any kind of relationship between someone's age and their height? Okay. Well, one way to begin to answer that is to create a scatter plot. Okay. And so I'm going to make a scatter plot. Okay. You guys remember graphing coordinate pairs in algebra? Yes?
Yeah.
Okay. That's all we are doing when we're making a scatter plot. Okay. We are graphing coordinate pairs. So on one axis we would have the age. So I'll start off at 20. On the other side we would have the height. So our first person is 24 and 76 inches tall. This person has a coordinate pair right there. Our next person is 22 and 70 inches tall. We put a dot right there. We have a 28-year-old who is 64 inches. Right around there. And 21 who is 68 inches. Okay, so these are just the 4 students for which we have collected data, and it looks like this. Okay. So these 4 data points come from this sample data that I've made up. Okay. And I'm going to just pretend like I've gathered more data from more students. Okay. So just to distinguish those, I'm going to use a different colored chalk, but these are just different people, could be different heights. We have short people, tall people at different ages. Maybe our data looks something like this at the end of the day. You guys see that? Okay. So again, this is all part of the same data, and I'm just using different color to indicate that these 4 points came from the data. But just imagine additional data that I didn't write out. Okay, so we have more data here. All right. Can any of us make some kind of general rules along the lines of students who are older tend to be taller, or students who are older tend to be shorter, or is there any kind of generalization that we can make? No, there doesn't seem to be any kind of trend or relationship between age and height for our set of data. We would say so when we look at the scatter plot, we can't say anything like older students tend to be taller or older students tend to be shorter or anything like that. There just doesn't seem to be any kind of relationship between age and height. Okay. However, what if we were to go to an elementary school? Okay. Would we see a relationship between the age and height of our students at an elementary school?
More so.
Okay. And what would what kind of trend would we see? Okay. We would see, I would say, a very strong relationship where we'd see younger students, kids in 1st and 2nd grade, so 6 and 7-year-olds, will be shorter than kids in 5th and 6th grade. So we will see a strong relationship between age and height. Of course, there will be tall 2nd graders and short 2nd graders. There will be tall 6th graders and short 6th graders. But overall, we would definitely see a relationship where older students are taller than the younger students. Okay. So depending on, what your data set, you may or may not see. So we'll say meanwhile, at an elementary school, now we can gather age and height data. And if we create a scatter plot, we'll see trend like this. So this dot, who does this represent? The tallest student and the oldest student, okay? Or, someone, so this is an old student, also the tallest student. Student right here.
Youngest. Shortest.
That's the youngest, not the shortest.
Oh, yeah.
Who's the shortest?
The other one.
That's this student down here, okay? But this is the youngest student, also one of the shortest, but not the shortest. Can we see that? Okay, so this is the youngest student. How do we know it's the youngest student?
It's closest to 0.
Okay. It's closest to 0 for the x-axis, which represents age. Okay? This is the youngest student. Okay? Short, but not the shortest. Does anyone have trouble seeing that? Okay. Meanwhile, this one right here, this is the shortest student. Okay. Is young, but not the youngest. This one, I guess this would be the oldest student and also the tallest, okay? The oldest student or the oldest student. So we're looking at age and height. Short student, young but not the youngest. Okay. And overall, the trend, we would say, older students tend to be taller. Younger students tend to be shorter. Is that okay with everyone? All right. So instead of saying older students, okay, we're going to say age is the x variable. Okay, so instead of saying older students, I'm going to say students with large x value. Okay, so x, again, remember x represents the age. And y represents what?
Height.
Height, okay? So we would say students with large x value tend to have large y or small y?
Large.
Large y, okay? Students with large x value tend to have large y value. Okay? So all I've done is I've changed older students, which just means your age is higher, into changing it to saying large x value, and where age x represents age. And I've just changed the word taller into meaning large y value, where y represents height. Okay? Is that translation okay?
Yes.
All right. So then the other student, younger students tend to be shorter. How would we write that? Students with small x values tend to have small y values. Okay? Good. Can I flip it around and say students with small y value tend to have small x value? Is that an okay statement? Yes, that's an okay statement. And I could also flip the other one around. Students with large y values tend to have large x values also. It's fine. Okay? This is an example of what we call a positive relationship. Large x corresponds to large y. Small x corresponds to small y. This is an example of a positive relationship. Okay? So large x corresponds to large y and vice versa. Small x corresponds to small y's, okay? In general, okay? This is a positive relationship. This is the general trend. Is it possible that there is a 6th grader who is shorter than a 2nd grader? Yes, it's possible, okay? That would be, you know, one student who doesn't fit the trend, okay? Maybe we have an unusually tall 2nd grader and maybe an unusually short 6th grader, okay? So, sure, there might be a few individual students who don't fit the overall trend, but overall, if we look at the students as a whole, we would see the trend where large X, or older students, correspond to large Y, taller heights, and the opposite, small X, younger students, tend to have small Y values, okay, shorter heights. Is that okay? So that's a positive relationship. What do you think a negative relationship looks like?
Like it happens the opposite. Like large value.
Okay, so in a negative relationship, large X corresponds to small y in general, and small x corresponds to large y in general. So a negative relationship, okay, so we'll have large X generally corresponds to small y, and small x generally corresponds to large y. Okay. Do I need to write out the full sentences? No. Okay. So that would be a negative relationship. Can we think of two numeric variables that might have a negative relationship? Okay. All right. What if? All right. So here's an example. Oh, you have an example in mind?
I don't know, but maybe what about age and life expectancy?
Age and life expectancy? Actually, so you're thinking age and how many more years you have left to live. Okay, so how many more years you have left to live is technically a little bit different from life expectancy. But yes, okay, your age and how many more years you have left to live will have a negative relationship. We generally don't know that number. But here's a simple example, okay? All right, just imagine you're looking at, I don't know, iPhone listings on Craigslist or eBay or whatever, okay? We can look at the age of the phone that's being sold versus its value, okay? So brand new phones. What is the age of a brand new phone?
6 months.
Okay. Brand new would be 0, right? Okay. So
When the iPhone came out first.
yeah. Okay. So a brand new okay. So yeah, I guess brand new iPhone, yeah, would be 0 months or 0 days old. Okay. You know, and we can look at new phones like a used iPhone 6 is probably just going to be a few months old. Okay. And they will be high in value. So they have small x values, small age numbers, but their sale price would be high. Okay? If someone is trying to sell like a iPhone 3, iPhone 3G, I don't even know if those are on the market. Okay?
No, they have those in museums now.
They have them in museums now. Okay. So you know, the age value, it's a few years, okay? Like maybe 4 years or 5 years, however many years, okay? Not that many years, but the sale value is much, much lower compared to the newer models, okay? So we would have large X, large age corresponds to low values. Small x, new phones compared have high resale values, okay? Yeah, used cars in general also fit this, but you get weird things like classic cars that are very old suddenly having extreme high values. So, but in general, if you're just looking at a general used car lot that doesn't specialize in these classic vehicles, then yes, you will have large age or high odometer readings corresponding to lower sale values, and lower odometer or lower age or whatever corresponding to higher sale values. Okay. So, example. So X could be age of the iPhone, and Y could be sale value. Okay. So phones with low age, or low X, tend to have high sale value, high Y, and vice versa. What are the subjects in this data set?
The phone, the age, and the sale value.
Okay, so each subject would be a listing for a phone. Okay, so each phone that is on sale would be a subject. Okay, so it's not the model, it's not all iPhone 6s or anything like that. It would be each individual phone that's on sale. Okay. All right. Would that be? And is the age of the phone the only thing that's going to determine the value of the phone?
Condition.
No, condition is going to be the other, will play a huge factor, okay? But age will play a strong factor as well, okay? So basically which model it is will correspond very closely to the age, and then the condition will be very, very important as well. And then other things like, I guess it would be factored into condition, like whether it's unlocked or not, right? Locked up because it might have been stolen or something, right? So different things, okay? So condition, on the other hand, is that a numeric or a categorical variable? Categorical. Well, so most of us would say it's categorical, okay? But you will see on like on eBay or whatever, people might assign a numeric value to the condition. They might say, on a scale of 0 to 10, this gets a 9, okay, or this might get a 7. So it's a subjective thing, okay. It's not like you put it on a scale and the scale says condition 6, okay. It's kind of a subjective opinion. And you kind of have to assume that the seller is going to be biased towards putting larger values than maybe someone who isn't trying to sell it. Okay, so anyway, we have positive relationships and negative relationships for when we're looking at two numeric variables at a time. And in the case where we were looking at our classroom, where we had, and we were looking at the age of students and their height, what we saw was no relationship, okay? So you might have a positive relationship, you might have a negative relationship, and it's also possible to have no relationship. Okay, so no relationship would mean looking at the x variable does not provide information about the y variable. And in the case of our classroom and we are looking at age and height, that would be the case. If we knew someone's age, does that give us an idea of whether the student is tall or short? No, it doesn't, okay? Whereas at the elementary school, if you were given someone's age, you would have an idea of whether or not the student is tall or short compared to the rest of the entire school. Maybe not within that student's age group, okay? So if we say, here's an 11-year-old, so that would generally be a 6th grader, we would not know if this student is tall or short for a 6th grade student, but compared to the overall school as a whole, we would expect the student to be on the taller side, okay? Same thing with the age of a phone being sold, okay? If I tell you the phone is only 6 months old, you would expect this phone to have a higher sale value in general than a phone that's 4 years old. Okay. No relationship with the next variable. Okay. All right. So this kind of hints at the idea of what we have. We have an x variable and a y variable. And we call one of these the dependent variable and the independent variable, or other names for it are the response and the predictor. Okay, so I'll write this down. We have independent variables. Also called the predictor. Okay, then we have the dependent variable. Also called the response. Okay. And the idea is that, and the independent variable is the x variable, and the response is the y variable. And the idea is that we will take the x variable, and based on the value of the x variable, we're trying to predict the value of the y variable. Based on the x variable, so the other names for the x variable are dependent variable, or the predictor. So based on the predictor, we are trying to make a prediction for the y variable. Based on the x variable, we're trying to make a prediction for the y variable. And sometimes the variables can be flipped around where you try to, you know, in one situation, one variable might be the predictor and the other variable would be the response, but you can flip it around so that one variable is the predictor and the other is the response. But whatever you call the x, you will be using that to make the prediction for y, okay? So if you call one thing the x, that is the predictor, that is the independent variable that you are using to predict the y, okay? If you flip them around, you have to rename them, switch them to x and y again, okay? So for example, in our example with the elementary school students, the idea there would be we're using the student's age to make a prediction for the student's height. So I might say a particular student is 10 years old. How tall do you think the student is? And you'd say the student's probably, I don't know, 56 inches tall or something like that. Okay, I don't know. And I might say, okay, another student is 7 years old. How tall do you think this student is? Okay, and you might say 7-year-old student, I predict this student is 48 inches tall. I don't know. Okay, I'm making up these numbers. I don't know what the average, I don't know the height of the average 7-year-old, but that's the idea, okay? So based on a student's age, knowing nothing else about the student, you're trying to make a prediction for the y variable. Okay, so based on the x, we try to make a prediction for the y. Okay, try to predict y, and the other part is using no other outside information, okay? Okay. So, based on a student's age, predict the student's height. Okay? You don't know if this student is a boy or a girl. You don't know if this student is, you know, whatever. All you know is the student's age. You're trying to make a prediction for the student's height. Based on the age of an iPhone, predict the iPhone's sale value. Okay? You don't know the condition. You don't know anything else about it. You just know the age of the iPhone. Okay, so that would be the other example. Okay, so in that case, so in both of these cases, the age is the x. And over here, the student's height, that would be the y. But we could play a different game. And I could say, well, this phone sold for 600 bucks. Predict how old this phone was. Is that a legitimate question to ask? Yeah, okay. And so in that case, the piece of information you're given is the sale value, and what you're trying to predict is the age. Okay? And so in that case, the sale value is now the new x, is now the dependent variable, and the age is now the dependent, or the response. Okay? So depending on the context that you're dealing in, and the question that you're asking is going to change what's the x and what's the y. Okay. Whatever you are using to make the prediction, that's the x. The thing that you are trying to predict, that's the y. Okay. Is that all right? Okay, so there's an example in the book that says we're looking at different textbooks, okay, and we count how many pages are in the textbook. And based on the number of pages, we're trying to, we want to predict how thick is this textbook, okay? So we're looking at the number of pages in a textbook. We're trying